The Sun, a blazing ball of plasma, a giant nuclear reactor in the sky. It's the heart of our solar system, a source of light, warmth, and life. For billions of years it has bathed our planet in its golden glow, a silent guardian allowing life to flourish on Earth. But even stars don't live forever. The Sun, like all stars, has a lifespan. It's a story of incredible energy, dramatic transformations, and ultimate demise. The good news is the Sun is currently in its prime, effortlessly fusing hydrogen into helium in its core, a process that releases the energy that sustains us. But this stability is not permanent. As we delve deeper into the life cycle of stars, we'll uncover the processes that fuel the Sun and understand what happens when this fuel eventually runs out. This journey will take us billions of years into the future, revealing the fate of our star and its impact on everything around it, including our own planet. Buckle up, as we are about to witness the wonders and the power of the cosmos on a grand scale. Deep within the Sun's core, a cosmic dance is taking place. Imagine a furnace, but instead of coal or wood, it's powered by hydrogen atoms. These atoms, under immense pressure and heat, are forced to fuse together, creating helium and releasing a tremendous amount of energy in the process. This process, known as nuclear fusion, is the engine that keeps the Sun shining. Think of it like squeezing pieces of Play-Doh together. The harder you squeeze, the more they stick and merge. In the Sun's core, gravity is the force that squeezes, and hydrogen atoms are the Play-Doh. This fusion process is incredibly efficient. A single gram of hydrogen fused into helium can release as much energy as burning tons of coal. This energy, in the form of light and heat, then radiates outwards, taking millions of years to reach the surface. From the surface, it bursts into space, illuminating and warming our solar system. This delicate balance between gravity pulling inwards and fusion pushing outwards is what keeps the Sun stable. However, this balance can't last forever. The Sun's hydrogen fuel, while vast, is finite. Like a car running low on gas, the Sun will eventually run out of fuel for its nuclear furnace. When this happens, the consequences for the Sun and the solar system will be dramatic and far-reaching. Billions of years in the future, a slow, inexorable change will begin to occur within the Sun. The hydrogen fuel in its core, the lifeblood of its energy production, will start to dwindle. As the hydrogen is consumed, the core will contract under its own gravity, becoming denser and hotter. Imagine a bonfire slowly dying down. The logs, once blazing brightly, begin to shrink and char as their fuel is consumed. Similarly, the Sun's core will shrink and heat up as it burns through its remaining hydrogen. This increase in temperature will have a profound effect on the Sun's outer layers. Like a balloon expanding near a heat source, the Sun's outer layers will begin to swell as the core heats up. The Sun will grow larger and brighter, its color shifting from yellow to a more reddish hue. Our once stable star will begin its transformation into a red giant, a celestial object far larger and more luminous than the Sun we know today. This transformation, however, is not a peaceful one. It marks the beginning of the Sun's decline, a slow but unstoppable march towards its eventual demise. And as the Sun changes, so too will the fate of the planets that orbit it, including our own. The red giant phase marks a dramatic turning point in the life of a star. No longer content to be a steady source of light and heat, the Sun will enter a period of instability and expansion. As the core continues to contract and heat up, the outer layers of the Sun will swell to an enormous size, engulfing the orbits of Mercury and Venus. Imagine a simmering pot of water on the stove. As the water heats, it expands and bubbles, sometimes even spitting drops of scalding liquid. The Sun's expansion into a red giant will be similar, but on a much grander scale. The solar wind, a stream of charged particles constantly flowing from the Sun, will intensify, pushing against the atmospheres of the remaining planets. Earth, if it escapes being completely engulfed by the expanding Sun, will be a very different place. The oceans will boil away, the surface will bake under the intense heat, and the atmosphere will be stripped away by the relentless solar wind. Life as we know it will be impossible. The red giant phase is a period of both creation and destruction. While the sun sheds its outer layers of spewing stellar material into space, it also sets the stage for its next transformation, a final act that will leave behind a beautiful cosmic remnant. Section 5. Scorched Earth, the red giant's impact. The sun's transformation into a red giant will have catastrophic consequences for Earth. Imagine our planet, once a vibrant blue and green oasis, slowly being scorched by the ever-intensifying heat. The once life-giving oceans will evaporate, turning into thick clouds of vapor that eventually get stripped away by the solar wind. The lush green landscapes will wither and turn to deserts, the very rocks baking under the relentless glare of the swollen sun. Temperatures on the surface will soar to unimaginable levels, making it impossible for any known life forms to survive. Even if some microscopic life forms manage to find refuge deep underground, the eventual fate of Earth is sealed. As the red giant phase progresses, the sun will pulsate, expanding and contracting, its gravitational pull fluctuating wildly. This instability could potentially fling Earth out of the solar system entirely, sending it hurtling through the cold vastness of interstellar space, a barren, lifeless rock forever banished from its life-giving star. Section 6. Planetary nebula, the sun's farewell. After billions of years as a red giant, the sun will begin its final act. The core, now mostly helium, will reach a critical temperature, igniting a new round of fusion that will convert helium into carbon and oxygen. This helium burning, however, will be short-lived and unstable, causing the sun to pulsate violently. These pulsations will be so powerful that they will rip away the sun's outer layers, flinging them out into space in a spectacular display. This ejected material, glowing brightly as it is energized by the dying star's radiation, will form a breathtaking shell of gas and dust known as a planetary nebula. Imagine a cosmic firework display, a final burst of brilliance from a star nearing the end of its life. The planetary nebula, though fleeting, will be visible for thousands of years, a silent testament to the sun's once mighty presence. Within this expanding cloud of stellar debris lies the story of the sun's life, from its birth in a cloud of gas and dust to its fiery demise, and at the heart of this cosmic spectacle will be the sun's transformed core, a faint glimmer in the darkness, ready to embark on its own solitary journey. Section 7. White dwarf, the cooling ember. As the planetary nebula fades, dispersing into the vastness of space, the sun's core will be revealed. No longer a raging inferno, it will have transformed into a white dwarf, an incredibly dense and hot stellar remnant. Imagine compressing the entire mass of the sun into an object the size of Earth. That's how dense a white dwarf is. This incredible density comes from the fact that a white dwarf is no longer supported by nuclear fusion. Instead, it's held up by a quantum mechanical effect known as electron degeneracy pressure, which prevents the core from collapsing further. Though incredibly hot at first, the white dwarf will have no internal energy source and will slowly cool over billions of years, radiating its remaining heat into space. Think of a dying ember in a fireplace, gradually fading from a bright orange glow to a dull red and eventually to blackness. The white dwarf, once a mighty star, will spend the rest of its existence as a silent, cooling ember, a ghostly reminder of the sun that once illuminated our solar system. Section 8. Life beyond the solar system's fate. With the sun's transformation into a white dwarf, the solar system as we know it will cease to exist. The once life-giving warmth of the sun will be a distant memory, replaced by the faint, fading glow of the white dwarf. The planets, their orbits disrupted by the sun's dramatic changes, will be left to wander the cold emptiness of interstellar space. Some planets may be flung out of the solar system entirely, becoming rogue planets destined to roam the galaxy alone. Others may remain loosely bound to the white dwarf, their frozen surfaces reflecting the dim light of their former star. Life, as we know it, will be impossible in this new, colder solar system. However, the seeds of life carried on comets and asteroids, flung outwards during the sun's death throes, could potentially find new homes around other stars. Perhaps on some distant world orbiting a young, vibrant star, life will get a second chance, a testament to the enduring power of life in the face of cosmic change. Section 9 conclusion. The universe keeps going. The death of the sun, while a dramatic event, is but a single chapter in the ongoing story of the universe. Stars are born, they live and they die, each stage playing a crucial role in the cosmic cycle of creation and destruction. The sun's death will enrich the interstellar medium with heavy elements, the building blocks of future stars and planets. The atoms that make up our bodies, forged in the heart of stars, will be returned to the cosmos, ready to participate in the formation of new worlds. The death of a star, while marking the end of an era, also represents a new beginning. As we contemplate the fate of our own star, we are reminded of the vastness of the universe and the interconnectedness of all things. The universe is a place of constant change, a cosmic dance of creation and destruction, and the death of the sun is just one small step in this grand, awe-inspiring process.